we're going to show you how a new piece of code works called analogWrite. And it's similar to digital write. I'll contrast the two, and we're going to write a little program, and we'll probably get tripped up more on the wiring than we will with the actual code. So let's jump into it. The idea is to set up a little circuit so we can demonstrate how analogWrite works. So I'm going to flip to this view, and we're going to build 3 series circuits simply using LEDs and resistors. We've done that several times before, but we're going to make 4 of them, and then we're going to control each one separately with the analogWrite, so you can get a feel for how that new piece of code works. So let's go ahead and build the circuit first. This is going to be the hard part, setting this up. Well, hopefully it's not that hard anymore because we've done this before. And we're also going to be needing to use these little pins with the squiggly lines next to them. That's going to kick in. Before we didn't care which ones we were using between 2 and 13, but now we got to differentiate between the squiggly lined ones and the ones that don't have that. We need the ones with the little sine wave next to them. Alright, although in my view it doesn't look like a wave. Here we can zoom in a little bit. There we go. Now we can see the little wave there. These are great for what we've done before, but now we're going to use these. Alright, zoom back out, center a little bit. Let's build these 3 circuits. Let's put one way over here. Let's put one a little further over. Actually, let's get a little big space in between these. Give ourselves lots of room. That looks pretty good. We need the same type of resistors, 330 or 220. Make sure each one is identical. You don't want one to be 1,000 and another one to be 220, because then you won't see what I'm trying to show you. So I don't know if it's worthwhile for me changing this every time, but maybe so. Let's say I'm using 330 every time. Let's put that one there. Let's grab another one. Switch to ohms. So where's the other? Whoa. Grab that. Put it here. And we need 2 more. Of course, when I do it with the Tinkercad, it takes almost no time at all, but when you're trying to push these into the breadboard, it takes a little longer, especially the new breadboards. They are really kind of stiff, a little bit more difficult to push into some of the holes on the breadboard. Anyway, so all mine are 330 ohms, and all my LEDs are the same. Now I need to send the cathode side to ground. All of them are going to be going to the same place, so we're going to use a little trick here. We're going to just send them down to this rail down here. And I do love Tinkercad because it shows you the entire row lights up green, letting me know that everything, all these dots are all in common. If I put anything in here, it's all going to be connected. So this wire and this wire and this wire and this wire are all nicely connected. And so I can send all of them at one time to ground. So that's pretty cool. I don't have enough grounds. I have 1, 2, 3. I couldn't even send 4 into there if I wanted to. So this is the technique we want to use. Now, for good practice, it would be nice to test our circuits, make sure they're working properly. And to do that, probably, for me, it's going to be really easy. If I pause for a minute and think about this, it's really worth doing this because, well, it is just one wire. Let me show you what I was thinking about having you do, and you decide if you think it's worth it. I was going to send all of these to 5 volts, and then I was going to send one of these, trying to grab the screen and get rid of this thing at the same time. There we go. Now we'll grab the screen. Send 1 all the way to 5 volts. And then test the whole thing. Great, all my circuits work. I'll you decide if it's worth doing that or not. I'm going to get rid of them now because I really need to send. I mean, it's probably worth it, especially if I look at. I'm looking down at my breadboard, which I built just before I started this, and there's a lot of big nest is what I call it. It's good to make sure I know my circuits are all working properly. So I'm going to go back and now individually zoom in a little more. Delete that wire, it's dangling there. Delete that one. I'm going to start setting these first one to 11, and I'm using again the one with the wave next to it. Explain why that is later. And this one I'm going to send to 10. Doesn't matter which one I send it to. I mean, I could put it in 6 or 5 or 3. Let's put that one in. Let's put that one in 3. Probably forget that I put that one in 3. Hopefully not. Well, we'll get an error and we'll solve the problem, right? So that looks pretty good. So we're going to send information out of our digital PWM pins. Off the side here, we kind of have a little hint as to what these waves mean. They stand for PWM, pulse width modulation. Don't worry about what that means right at the moment. Looks good, just checking things over. Let's jump to writing our code. Get rid of that, and open up the this IDE. It's been kind to me. It's going faster, the Microsoft Store download one. Let's just do a new one. That's probably something else I was working on. Infrared sensor, a future project. And let's make it a little bigger so you can see it. Now it looks pretty good. They always default these comments in here, and they always just sort of get in the way. And give us a little space. All right, I'm not going to worry about actually putting in, I'm not going to declare any variables. The program's just too small to, it'd be adding a lot of extra work and not serving any purpose to make variables, put those variables in for the numbers, as you will see. Since I am sending information out of my pins, let's go back to the other one, see if I can get both of them on the same screen here, even though I'm blocking part of it. Let's try that. Mainly to remind me what pins I was using. Now it's gone. I got what I needed though. I needed 3. I knew I'd forget 3 for some reason, I don't know why. And it's going to be an output. Pin mode. Oh boy. 9, 10, 11 is what I'm using next. So 9. That looks good. Spell right, changes color, lets me know. 10. Looks fabulous. And 11. All right. That looks pretty good. So I'm telling the program to expect to have something coming out of those pins. Quick double check. 11, 10, 9. Oh, that's good. Now we're going to use our analogWrite. analogWrite. Now, before I enter something in here, let me remind you what digital write did. First off, we have these little parentheses, and sometimes you want to input one little bit of information, like delay, for example. I want to put in a single number, 399, it's a weird one to put in, 300 say. And what I'm inputting is called a parameter. So some functions want a single parameter and some of them want two. SDJH, as you remember, needed two parameters. It wanted the pin number, say 3, and in the next parameter was, you want, am I sending 5 volts out or 0 volts out? And so you'd put high or low here. And then, of course, end the statement here. analogWrite also requires two parameters. It requires a pin, and this next step is a little more complicated, but also makes analogWrite a little more powerful. With SDJH, all we could output was a high or a low, a 5 volt or a 0 volt. It could even be 3.3 volts. We could decide what the high is, but with analogWrite, we can now make some choices. We don't have to have it be just 5 volts. We can have it be 4 volts or 3 volts or 2 volts or something in between. And this is going to be a little confusing because I don't just say like, 4 volts. I want it to be 4 volts coming out of there or something like that. This information that you're entering into the second parameter, so X basically, it's going to be a 8-bit or 1 byte piece of information that we need to put in there. And I know that's confusing. I haven't really gone over bits and bytes. We'll have to do that in a later lesson. But 8 bits make a byte, and 8 bits are 256 available integers. So we're going to be putting a number in here between 0 and 255. The 0 counts as a value, so instead of up to 256, 8 bits, we're going to have a 0 and up to 255. Now, if you're ever confused and you don't have anything in your notes, you're like, Mr. Brower, I don't get this, or I need a little more information about this, or I'm doing something new. What's very, very useful is, let's say I'm trying to study analogWrite. I'll type that in, and then I'll do Arduino, and it'll take me to this Arduino reference page. I got a couple choices here. I mean, I go right to this web page and then look under references, but that usually is the slower route. And so you'll recognize kind of the colors here. It's just the same people that make this IDE, and they'll tell you a little more about it. In this case, analogRead. Did I type in analogRead accidentally instead of analogWrite? No, I did not. That is weird. I got analogWrite, but it's telling me about analogRead, which is another useful function, but I got a little spelling error going on. Maybe that'll help. Got the I on the wrong side. Let's see if that helps. All right, there we go. There we go. Now we got analogWrite. Some of this might be a lot of nonsense, but at least you got access to all the little details of how this works. There's analogWrite, talks about the two parameters it needs, the pin and the value's got to be between 0 and 255. So whatever goes in here, this part in particular I like. Right here, the syntax, what I need to write as far as the code goes, and the parameters, what each of these two values mean and what it's expecting. And then some examples of it in use. So really neat resource. Okay, so what we're going to do, a function of this project, which I didn't mention at the beginning because it wouldn't have made much sense, I don't think, until now, is we're going to put in different values for our analog. Actually, get rid of this because this was just our example of previous knowledge. We're going to put in different values and show you what the effect is on the LED. The cool thing about doing this circuit stuff in Arduino stuff is you're just doing lots of little experiments, which is really cool. And in this case, we're going to try out what a parameter of 0 means for analogWrite. Let's try out what a value of, let's not talk and work at the same time. So I'm going to put in a value of 0, and let's do analogWrite. Next pin over is 9. And let's give it a value of, we got to go from 0 to 255. Let's jump up to like 75. Just kind of making that up. Kind of want these to inch up a little bit. Let's go to pin 10. And let's send maybe 150 to that one and see what the effect of that is. analogWrite, and let's do the last one. I did 4 of them. And let's send this one all the way to 255. I got kind of a big gap between 75 and 50, but whatever. Just kind of spreading these out a little bit so we can test out how things work. And I need to look, I'm looking down at my circuit board here, and I actually have one of my pins in 6 and not 3. So let's flip that to 3. Okay, now if you're using this IDE, I need to plug in my, let's make my view a little bigger of me. There we go. So I'm looking down here at my board and all my bird's nest here of wires, and I've got it plugged in, it's powered up. I got to always check to make sure it's got the right board, which you'll notice it usually finds that one, but occasionally or accidentally, usually it's on another one. And depending on which ID you use, sometimes you can find this automatically for you, and sometimes it doesn't. You got to select the one for our Arduino board. So it's using 18. Now I'm going to upload this. Wants me to save it. I don't not too particularly interested in saving it. You're welcome to build a little file and put everything in a folder somewhere. Keep all your work. All right, so nice. Everything worked nice and no errors. I'm looking down at my circuit, and I can show you what I've got, but it's really hard to see with my video camera. Basically, the first one is completely off. The second one over looks like it's got a line through the middle, but it's actually fairly dim. And the other two, the next one over is a little bit brighter, and the last one is really bright. Now the last two are kind of hard to distinguish. If you hold it up sideways, it's a little easier. If I'm holding my LEDs up, I'm looking this way as opposed to straight down, I can get a better sense that, yeah, it is getting a little bit brighter as I go across. Now, if you're not seeing this, I actually just pre-built this before I started the video, and the third one over was for some reason really dim, and I'm looking through my code and I'm wondering, what is going on here? Everything looks good. And you got to think through this and try to ponder this, which is, again, the real cool part of doing this kind of work. And I thought, well, maybe I got the wrong resistor in there. Maybe it's not a 330. Maybe they're not all the exact same. So I pulled it out, tested it with my multimeter, and it turned out to be 1,000 ohms. So it automatically made that one dimmer because it was a larger value. And now it looks fine. All right. So that was it for today. analogWrite. Instead of having it just be a little recap here, instead of having digital write, where we're writing a message, our message is how much voltage do you want? Instead of just saying it's going to be high or low, on or off, now we can fine tune this and say, now we want a little bit of voltage, or we want a lot, or whatever. So it's fairly easy to use. You just got to remember to use. Matter of fact, a good comment for this would be, we did comments in another video, would be something like, remember to use the, I like to call them the sine pins, but let's call it the wave digital pins, not the others. All right, so that is it. We'll show you another project in a little bit.